Everybody, if you're not sitting down, if you'd like to sit down, and we'll make a start. I can't really hear if you can hear. Can you hear me okay? Yeah, cool, okay. As long as you didn't say no then, and I would be confused. So, thank you all for coming. Welcome to Sainsbury's. I'm Beth, I'm one of the organisers. And I've now got a yellow t-shirt for those keeping an eye on their things. So, this evening we're going to have a few words from our sponsors. We're going to hear from Nick Wells about panicking, or probably not panicking. We're going to hear from Paul about some test script. We're going to have a break, a few more drinks, and then Benjamin Bryant is going to talk about the Go in production experience. And then we're going to, as tradition dictates, socialise and go for a beer afterwards if you choose to do so, or a non-alcoholic drink. There are also some posters, the Go 10-year celebration posters, and we're going to be handing those out at the end, so stick around for those, to put one of those on your bedroom wall. That'll look great. So I'd like to welcome Simone from Sainsbury's up to the stage to say a few words.
LondonGophers, welcome. First, I would like the other way around. Yes. First, a little announcement. We do not expect a fire drill this evening, so if you hear a fire alarm, it's the real thing. In that case, please make your way to the nearest exits, which are located at the corners of the theatre, and just follow the signs until you get outside. Please do not use the lifts. Right, so this is our second meetup that we host here at Sainsbury's, and some of you may be wondering why a grocery retailer is hosting a technological meetup. And that is because Sainsbury's is actually very active in the technology world. We believe in tech, and we invested in it to the point that we actually created a whole new brand called Sainsbury's Tech, which encompasses anything technology in all of the brands of the group. I've been here for a little more than a year, and I really enjoy being part of Sainsbury's. One of the great things about working for Sainsbury's is that you get to work on applications that really have to scale. One example, for instance, is Groceries Online, our e-commerce platform that currently is installed on more than 1 million iOS devices and more than 700,000 Android devices, and deals with more than 32 million sessions per week. Another application that really has to scale is one close to my heart because I am part of that team, and that is Smart Shop, those little handsets you use to scan your own shopping. When I joined the team, we were available in 69 stores. Now we're available in more than 500 stores and counting. In a normal week, we deal with more than 250,000 transactions, full end-to-end journeys. And on a normal Saturday, our services deal with more than 10,000 requests per minute. Another great thing about working for Sainsbury's is that we get to use technologies such as Go, cutting-edge technologies, and one gets to work with engineers that use this technology to build these applications that have to scale. The environment is quite open and friendly, and there is so much you can learn from all of the other team members. If this sounds like a plug, it's because it is. We are hiring. We have a number of open roles, some of which are Go, but we use a range of stacks. So if I perk your interest, if you like what you hear, please come and just talk to me or anyone with a black lanyard. And yeah, love to hear from you. This is it from me, so I'll hand the microphone back to the organizers. It is great to see so many of you here, and I really hope you enjoy the talks we have for you this evening. Thank you.
And we might even have some fans of the BBC documentary Inside the Supermarket here as well. So, get on that. So, just some regular housekeeping. The post-event social is going to be at the Draft House, which is just around the corner. So it's kind of, I'm not sure which direction I'm facing now, but there's a map here, and you can find someone in a yellow t-shirt to follow down there if you like. So the first talk is by Nick Wells, and it's entitled Panic. Please welcome Nick.
So I'll just put that anyway. Okay. Okay, I seem to have lost it. Not sure what's happening. I can't find the. There's the other window which was off the screen.
Panic over.
Yeah. Right. So. Okay. Okay. So the first panic was getting the slides up. Okay. So I'm going to be talking tonight about panic. It's a feature in Go, and we'll be talking about that tonight. So I'll be covering what panic is, what you see when you get a panic, how to regain control after a panic, We'll talk a little bit about runtime panics and how to identify them, and then there'll be some advice on when and how you should panic and when and how you should recover. Okay, so basics is it's a mechanism that Go offers, and it's used for handling and reporting runtime errors. It gives you a lot of detail about where the problem happened. Your program exits, and if you don't want to exit, you have to call recover in a deferred function. And be very careful when you call recover, because there's a lot of gotchas in there. So let's get a bit more detail. So as I say, it's a built-in function. It takes a single argument of the empty interface. You can pass anything into it. And it's used by the runtime and the standard library to report errors that can't be caught at compile time. And you can use it too. And there's some examples there of how you might call it yourself. And it is a function. It's not a keyword or some magic in the language. And it will appear in stack traces if you look for it. So here's the example we're going to work through. This is a bit of code that will panic. So we've got a function. So main calls function f. F defers a print line statement and calls this function panicker. Panicker is supposed to return a couple of values, and the first things it does is it defers a couple of more functions, and then it prints out a little message saying it's about to panic and panics, and then there's a bit of code after that. So what happens when you panic? The first thing is the execution of the current function stops. So no more of that. So no more of the code. None of the code after the panic statement on line 23 gets run. So 25, 26 and 27, those lines do not get executed. The next thing is any deferred functions are run. So in fact, the only thing that gets run after you call panic is deferred functions. They're called in the reverse order that they're defined, or that they were deferred rather. So it's last in, first out. And only those functions deferred before the call to panic are called. And it calls all of them in the call stack up, all the way up until it either exits or it gets caught. And they're called from the panic function itself. So it isn't stack unwinding isn't happening. It looks a little bit like stack unwinding is happening, but it isn't. And it's only the deferred functions in the current Go routine as well. So if you've got lots of Go routines running, the only deferred functions that you get called are the ones in your current function, in your current Go routine, the panicking Go routine. So next thing that happens is that the panic is reported, and this means it prints out the word panic and then the value that you passed to panic and a stack showing you where the panic occurred, and we'll talk about this more later. Then the program exits, and it exits with exit status 2, so you know if you've got another exit status, it wasn't a panic that killed your program. And here's what you see. So this is the output. So you see the about to panic message, which was the first thing that we printed in our panicker function. Then you see the deferred function called in reverse order. So the last is first and the first is last. And then you get the deferred function from the function that called it. And then there's the output from panic. So you see the panic message, you see the panic string, then the message that you passed, and then some details about what get called. So it shows you that main called F and F called panicker, and it shows you the file names and line numbers. So what happens if you panic when you're already panicking? So if one of your deferred functions itself calls panic, then the value that any subsequent call to recover will return is replaced with a new one. So you don't get both of the values, you just get the latest one in there, and you get the new panic location added to the stack, and we talk about that later. I'll show you an example. It's actually probably a bit more likely than you might think, because if you're panicking, your program's in an unexpected state. You thought something was happening and it wasn't. You thought the program was in a certain state and it wasn't, so it's a bit more likely to happen again. So that's an explanation of what panic is and what happens when you panic. So let's talk about what you see when you panic. So just to recap, it prints out panic and the value passed to the function and stack trace. The messages are written to standard error, which might be of interest if you're looking to capture them in when you're running your program. So the stack trace shows you for each stack frame you get the function being called with the first 10 parameter values and return values, file name and the line number, and you only see the stack trace for the panicking go routine, which I've said before. Just worth noting that the parameter values shown are the first 10 words on the stack rather than the actual the first 10 parameters as such, and because some values take more than one word. Okay, so whoopsie-daisy. Right, so here's an example of a runtime panic. This code will panic. You're doing a divide by 0, the runtime will catch that and give you a nice error message, and here's what you see. So this is a runtime error, so you get the runtime error string in front of it saying that it's from the runtime, and it's saying it's an integer divide by 0, so it's very clear what your problem was, and it shows you the line, the file name and the line number where it happened from, and that's it. So now let's have a look at another thing that will panic. So this is the standard library, so the flag package. If you try and call the flag package with two flags of the same name, you'll get a panic. And so that's the error, and if we run it we see this, and the first line is actually printed out by the library, so the flag package is printing out that line, and then the rest of it is from the panic mechanism. So you see the panic string and the details of the value that was passed to panic. And now there's a little bit more interest in this because it's a bit more to it. So you see main calls flag int, and it calls it from line 14 in main.go. And then you remember I said that the first 10 parameters are printed out. Well, we're not seeing that here, and that's because flag.int is a very simple function which just calls the int method on the flag set object, and it uses some default value. So if you use it in this way, you get the default some default flag set, and so the parameters. So the compiler has optimized the code away, and so if you see these ellipses as the parameter values, that's kind of what it means. It means that it's just been optimized out. But then, if you see up here, you've got a number of values on there. So the first thing looks like a pointer. The second thing looks a bit like a pointer, and then there's a value 1, and then there's a value 2. Another thing that looks a bit like a pointer, a value 4, and another pointer. And what's actually happening here is the first value being passed is the pointer to the flag set. So this is actually what gets passed around. So that notation of calling flag set.int is a bit of syntactic sugar really to make the language a bit nicer, but actually it's just putting it onto the stack. The next two values are the first string we passed in. So if you recall, back here, passed in a string of length 1 with value f, and then a 2, and then a string of length 4, value help. And so that's what we're seeing there. So we're seeing a pointer to the string, the length of the string, and that's what you see when you pass a string on the stack. Then there's a value 2, then a pointer to the second string and the length of the string, and then the last value is the return value. Okay, and then it carries on and does some more things, but essentially that's the meat of what's happening there. Okay, so if you want to control the information that you get when you panic, you can set the go traceback environment variable. The default value is probably fine for most purposes, but if you're having problems understanding why your program is panicking and you want to understand a bit more detail of what's going on in the program, you can set it to other values. I'm not going to talk about it more now, but that's something you can be aware of. So there. So we talked now about what panic is and what you see when you panic. So let's talk about how you get control back after a panic. So you need to call recover, and you need to call it from a deferred function. And the reason for this is because the only code that gets run after a panic is code in deferred functions. So it has to be in a deferred function, and the panic will not be propagated any further, and the function that you set up the deferred recover from will still return after all its deferred functions have been called. So there's an example here of how you of a way of calling recover. I'd personally recommend doing a little bit more. If you are going to recover, do more with it than just print it out. The default behavior is kind of better than that, but that's just for an example. Okay, so once you've recovered, you need to test the return value. This is the value that's passed a panic, and if it's non-nil, then a panic has occurred, and you can try to fix it. So that's the determinant of whether a panic has occurred. But unfortunately, the behaviour of the design of this feature in the language doesn't actually give you a guarantee that you're not in a panic if you do see nil, because you can panic with a nil value. Now, you shouldn't do that, but we'll come to a bit more arguments about what you should and shouldn't pass. But it can happen by accident. So, okay, so that's how you gain control after a panic. So now let's talk a little bit about runtime panics. So, if you want to know whether the panic that you received was a runtime error, you can tell by checking the type. So there's runtime errors are of a specific type, and it's a type of runtime.error. And okay, so a runtime.error, it's an interface with an error method, so that it satisfies the error interface. So it's a normal error, and it has a runtime error method which actually doesn't do anything, and it's useful to be able to distinguish a runtime error from other errors. If you want to have your own package-specific error type, this is kind of the boilerplate code that you'd need to have. Essentially, you just do as I've described for the runtime one. And so now, more interestingly, why should you have a package-specific error type? The main advantage is so that you can identify programmatically that an error came from your package. And in this example here, I've set up a type. It's not an error type, but it's just any old type here. So so my type is a string, and in the recover, if you assert that that the panic value is of your type, then it will panic if it isn't. So if you're expecting your code to panic with a certain type of error, you can panic with that error where you use it, and in your recovery, if it's not of that type, so something unexpected has happened, you can just do that assertion, and this code will re-panic. So as shown down there, the panic that we pass is just a normal string. It's not a my type of that string. So what you're doing here is you're using a sentinel error type rather than a sentinel error value. It's safer than sentinel error values. So Dave Cheney's written about the dangers of these things. Okay, and this is what you see if you get the wrong type. So you notice here you get two reports of panic. So the first one, panic knows that it's recovered the first one, and then it tells you the second error, which is an interface conversion. And then you see that main called main F5, which called panic. So we don't normally see that, but that appears because there's more code going on. So it's called the that closure function that we had in there that was asserting the type of the panic, and then that panics at line 98, which is wherever. Okay. So that's a description of runtime panics. Now let's talk about some advice on when and how to use this mechanism. Should you ever panic? Yes, you should. There are times when it's the right thing to do. So you should do it when you get something at runtime that's an unrecoverable programming error. You want the program to exit, giving details of where the mistake was made. That's the key thing. You should treat a panic almost like a compiler error. It's a bug in your code. You've got some behaviour which you don't expect to see, and the language has nicely reported it to you. It tells you exactly what line of your code was at fault and so on. So now, ideally you want to panic if you can. You want to make sure that any panics you might get are early on in the program as it starts up, so that you're not crashing some long-running program. But if there's nothing sensible that a caller of your function can do with an error except to exit, then panic is a reasonable thing to do. The Go standard library uses it. The flag package, as we saw earlier, uses it. If you try and set up two parameters with the same name, it doesn't make any sense. There's nothing useful it can do. And similarly, the regex package has a must compile function which will panic if you try and pass an invalid regular expression. So what should you pass to panic? So a simple string's okay, but an error is better. The benefit of this being that you can then distinguish between specific error types, as we discussed earlier. And don't pass nil, because if you do pass a nil, even by accident, then any recover that you try and do will not be able to know that it has recovered. It won't be able to know that it was recovering from a panic. It'll just think it's a no-op effect, or it looks like it anyway. Okay, so that's some advice on when and how you should panic. Now, how about recovery? This is where it gets a bit more complicated. So you shouldn't panic when you're getting an unrecoverable error. So you don't want to recover really from runtime errors. If you've tried to dereference a nil pointer, or you've divided by 0, or all of the other numerous things that can go wrong, you kind of want your program to exit. It's better that it exits rather than trying to limp along in some bad state, and especially if it's at startup. So that's one of the things with the flag package. It's typically set up at the start of main before you've passed any parameters. So it's a very reasonable place for it to crash, and it will happen as soon as you start your program up. So as long as you've tested it at least to the extent of running it, you'll know about the bug. Okay. So you might want to use recover if the package is using panic to report errors. So if you're using a package that's using panic as an exception mechanism, then you need to recover. And so we'll talk a little bit about how to recover safely. Also, you might disagree with the package author's assessment of the recoverableness. It might be that you're trying to set something up, but if it's not available, you can work around it. So you might be prepared to recover then, though typically you should have set it up correctly. Okay, another good place to recover is in tests. So if you've got some code in your package that's trying to that's making sure that you're doing everything properly, then you want to test that it panics in the right place, and so having it in tests is perfectly valid. One of the sort of exceptional places you might want to do it is if you've got a server where you're really concerned about availability. So you've got something where it maybe costs the company an awful lot of money if it ever actually isn't available, or if it fails in some way. So you might want to try and recover from a panic and try and institute some sort of disaster recovery mode where, for instance, starting up another instance of the server, and then when that other instance is up, then you can stop receiving new work and just finish off any work that you've got. So you might want to do that, but you want to be very careful how you do that, because, as I say, your program's in an unexpected state. Especially if it's a runtime error, it's quite likely that other things will fail too. So be careful. You will see panic and recover used as an exception mechanism. It can be used to you can use it to avoid having lots of if error not equal to nil return error code in your scattered through your functions. So if you've got a deeply nested sort of tree of function calls, it can be a bit ugly to have that sort of pattern all the way through, and that's the sort of thing that people were trying to do with the was it try the mechanism they were going to put in? I think it was, wasn't it? So you can end up with slightly more elegant code by doing it, and it mirrors the way that C++ and Java do things. The problems with it are it's a form of non-local goto. So you've got to be, when you're trying to understand what a program's doing, if you've got if error not equal to nil, then do this, you know what it's doing. It's very clear. With this sort of exception mechanism, it's the same problem that other languages face. C++ is the one I know best, and you get that same problem that at every point you've got to be able to recover if there's a sort of somebody just returning randomly after a function call because an exception was thrown, or in this case a panic was thrown above it. So be careful with it. It can make your code a bit more elegant. It might be useful. It might be the right thing to do in a small program where you've got this behaviour, but programs tend to grow. Libraries that are being worked, or packages that are being worked on by lots of people, tend to have long lifespans and get worked on by a lot of people who aren't so familiar with how it's working. So be careful with it. Okay, so now let's talk about recovery a bit more, about when you really, really must recover and carry on. Let's see how we should do that. So, problems that you have. If your function is recovered, if you've got a defer recovery in your code, then in a function, then that function will return. And typically it returns with no indication that anything was wrong. So let's talk about that a bit more. So it's about named and unnamed return values. So if you have a function with unnamed return values, then when you recover, those return values will always take on the default values. So numbers are 0, bools are false, strings are empty, and errors, most importantly, are nil. So in this example, as it says at the bottom, this returns 0 for the int, an empty string, and a nil error. So as far as the core of this function is concerned, everything's worked. So if you are going to have this sort of behaviour, you've got to make sure that having returned, everything's fine. So you've got to be very careful when you do this. It's not quite enough to just recover and carry on. I think the best approach is to have named return values, and then, as shown down here, if you do recover from a panic, explicitly set the values to known values, and maybe set the error to be some non-nil value, and say, so that people can know that something's happened. Okay, actually one more. Yeah, so actually this, just coming back to the issue around nil panics. If you do have a nil panic, this code can't do the right thing. It will still recover, but so the panic won't be propagated any further, but you won't go through any of this protection code here of setting an error and forcing all of the return values to known state. Okay, so another problem with it. This is coming back to the issue around the sort of exception mechanism, is that the behaviour of a function is more complicated than reading the code might imply. You've got to assume there can be a return statement after any line if there's a panic. Now, if all you're going to do at the end of all of this is to print out a stack trace and a helpful error message and then exit, that's probably okay. I mean, your program's sort of kind of in a bad state anyway, so exiting's fine. If you're hoping to carry on, then you need to really understand exactly the state that your program is after any of these states. So you can't assume that code lower down in a function is going to get called if you have a panic. This is kind of quite an important one. So if you've got tidy up code not in a deferred function, then it doesn't get called. So you see a lot of the time you have a file is open. You open a file and then you defer the close. Now that's good. If you don't defer it and you just say, oh no, I'll just remember, I'll close it on the last line just before I return, then that close won't happen. So you'll get a leak of a file descriptor there. Now there's been there have been some performance problems with defer in the past. They're minor. They're not very important anyway, but if you really really are concerned about them, they're getting substantially resolved in Go 1.14. So there's been some very sort of clever work done on that. So use defer. It's the right way to do things. It's a very nice feature in Go as well. It's a good thing. So when you recover, checking the panic values. So you can check to see if it's a runtime error, and then decide whether you really want to recover, but probably best is to actually check that it's explicitly a type of error that you are interested, that you are expecting, and repanic if it isn't. So that was the example we saw a little bit earlier. Okay. So that's mostly it. There's a bit of bonus material here now. So as I've discussed through this talk, there are a few problems with recover. Firstly, you only see the latest panic value. If you panic and then one of your deferred functions panics again, you only see that second panic. You only see the value of that. So somebody might have given you a nice, helpful message at the sort of lower down, telling you what the problem was, but you lose that because it gets overwritten by the latest panic value, and you can't detect that panic has been called if a nil value is passed. And so, kind of a proposal, if anybody from the Go language team is listening to this, might be nice to have a new recover function, recover all, which can return a slice of interfaces. So this then, you can know that a panic has occurred if this slice isn't empty, if the length of the slice is non-zero, and you can also determine all of the panic values you've got. So it's more useful if you want to sort of understand a bit. If you want to do recover, this is more useful. Okay, so these slides, which I've gone through quite quickly, they're available on GitHub. And there's speaker's notes with them, so you can sort of read what I've been saying. There's a few example programs, and there's a little program that sort of demonstrates how panic behaves. And also in that, under my GitHub stuff, there's a little utility program for, provides you with a package specific error type. So it just writes the boilerplate code for you. Okay, that's it. I hope everybody understands panic a little better than they did at the start of the talk, and good luck. Okay, right, take this off.
Great, thank you for bearing with us. So it's always a struggle with technology, and if anyone wants to start a startup that solves these problems, I'm in. But I think it might be a bit of a challenging problem. So thanks to Nick, that was really great. I think if anyone tells you don't panic, you can say, well, I'm going to, but I know how to recover. So it's kind of... yeah, so we're online as well, as you might know. We're on Twitter at LondonGophers. We're on Meetup, which you must have found tonight on. There's also a Slack workspace, the link up there, and the channel that we hang out in mostly is #London, sorry. And we're also on YouTube as well, which we're live streaming tonight. A quick and regular mention for the study group. The study group is kind of a sister group to this one, and it tends to trail this meetup by about a week. So if you're interested in doing a bit more kind of talking and studying about Go, that's the location. There is a Slack channel in the same workspace at London Study Group. There's a meetup, and the next meetup is next Wednesday, week today, and that's at Ates, just down the road. We have our regular raffle, so get your phones out and start entering. So if you go to gophers.london/raffle, and the keyword you need is grocery. If you put that keyword in, you can be put into a hat to win a JetBrains license, which is a pretty cool prize. You might have heard as well, GopherCon Europe or GopherCon EU is coming up soon, and we can offer you a discount. So if you use the discount code WeLoveGophers at gophercon.berlin, you can get a discount there. I believe it's 10%. It's quite a good one. I'll remind you of these later on. And also, you might have heard that .go is on again this year. This is the European Go Conference, or European Go Conference in Paris on March 30th. A quick note that you can submit a lightning talk to this conference now. It's at .go.eu/LT, and then you can fill out the form to submit a lightning talk. But also another discount, 10% discount this using the code GOLONDON. So you can use that one too. I'll remind you of that later on. And even more excitingly, we're running another raffle tonight to win a ticket to Go EU. So you can see a few more phones. So if you go to gophers.london/.go, use the code PARIS, that's where it is, then you might be in the running to win a ticket to .go, which is pretty rad. I'll remind you of those later on. So our next talk tonight is Paul Jolly, who you will all know, and he's talking about test script, putting the fun back in testing. So let's see if it really is fun. Thanks, Paul.
Yeah, I'm just gonna. Hi everyone, I'm actually standing in for someone who had to pull out at the last minute, so bear with me this evening. This is a pull together at the last minute, and I'm going to be doing live coding, which is an amazing combination. So the plan is to put the fun back into testing, although you'll spot that there isn't fun in the word testing. So what is test script? That's the theme of tonight's talk. So we're going to look at what test script is, and then we go into live code very badly, a simple program that uses test script, and try and convince you it's actually a really good approach to testing specifically command line programs, but actually anything. So what is test script? That's the package path there for test script. It provides a support for defining file system based tests by creating scripts in a directory. So we're going to unpack that over the next few slides. It was originally written by Russ Cox, and it's used extensively as part of the Go command tests in the Go distribution. So you can actually go and have a look in the Go distribution and see, I think now, hundreds of test script tests. It was extracted from being an internal package within the Go distribution to being a package that you can import and use by Roger Pepe. And Roger's been the person who's put in the majority of the work, so we have him to thank, as well as Russ, for all this work. So continuing this question, you pass test script itself, and there's a run function, we'll see this in a minute, a directory, the name of a directory that contains a number of scripts. Each script is a special text archive, and we're going to see what that actually means just below there. But it has generally at the top of it some shell-like commands that are the thing that the script itself, where you're sort of going to be asserting things, performing various commands, followed by 0 or more supporting files, and so that's the archive bit of it. So it's a script and an archive, like a tar file, combined, all in one text file. So as you can see at the bottom here, I've got a very simple comment on the first line there that says hello world, so this looks quite shell-like. Second command there is exec, which sort of you understand what that might be. It's going to say then call the cat command in your standard shell and pass in hello text, the file name. And then there's a comparison there from the result of the previous line saying, does standard out match the string, that regular expression that we're passing in there? And we're also asserting that standard error doesn't include anything in this situation. So you can see the reference to hello.text there on the second line. That is where the file contents itself, hello.text, are defined within the same script file. And this is the archive bit. So there you've actually got your test, that is the script at the top, and the supporting files all defined within the same file. And that's kind of convenient, particularly when you have small tests like this. So each script, when it comes to run, runs in a fresh working directory, available as an environment variable as $work. There's some sort of pseudo isolation here. This is not Docker level isolation going on, but it all runs in with a separate home directory and a separate temp directory as well. So really you have some degree of isolation there, but clearly this is not, as I said, Docker level isolation. So the supporting files, and hello.text is one of those supporting files here, are extracted, unpacked relative to our working directory. And then the script begins with a working directory of the work directory, if that makes sense. So that's why in this situation here, exec cat hello.text kind of works, because it's all happening within that same work directory. So the command script looks like shell. Is it? No, it's not. It's just a very simple language that has been defined. It's intended to look like shell, but it is much less powerful. The script, unlike bash, which will actually continue, a bash script will continue if there are errors unless you do something special. This script will actually stop if it hits anything unexpected, any error, a command that exits with a non-zero exit code, unless it's been negated, for example. So as I said, it supports negation, accessing and setting environment variables, end-of-line comments, quoting command words, and very basic conditions, but not if-else constructs like you might find in bash or other scripts. Are there any predefined commands? Yes, there are. CD for change directory, chmod. So you can sort of get a feeling for why this is like a subset or a very limited form of bash or one of the other scripting languages. And the link to the full docs is, will give you the full list of predefined commands. So enough of talk, because I can see everybody falling asleep. This is where it's going to go badly wrong. So here I have a very simple package main, and we're just going to get started here by saying format.println hello world. Okay, very simple. And then here we're just going to say go run. Are we in the right directory? Go, yes we are. Go run main.go. Fantastic, working. So we think this is actually a bit boring. So what I'm now going to do is actually define a flag that allows me to specify what the greeting is and the target of who we're greeting. So let's define two flags to do that. So let's say fGreeting, if I can type, equals flag.string greeting, and we're going to say make the default be hello, and then we're going to have what greeting. Sorry, I'm not feeling very creative here. And then we're going to have fTarget equal flag.string, target, and then we're going to have world, let's be the default, who are we greeting. Okay, and then I must remember to do flag.parse down here. Please shout out if I'm actually making any errors as we go. Which is good, okay. So now let's try this with greeting, different greeting. Let me just clear this. with a separate greeting of hi. Oh, of course I haven't. That was a bit obvious, wasn't it? Goodness me. Come on, shout these things out. This isn't going to work otherwise. Okay, F greeting. Okay, hopefully that looks a bit better. Anything else? Then we'll carry on. Yes. Even better. Fine. So now we think, oh, this is great, but I'd like to write some tests. So how would you actually start testing a program like this? You think, okay, could write a test, and then how would I invoke main, and how would I check that what's printed as standard out is what I expect? It starts to get pretty ugly pretty quickly. And this is just a very basic command line application, but think of something like the command go, which is hugely complicated with a huge number of subcommands. Where do you actually start on all of that? So this is where test script comes in. And so what we're going to do is, first of all, before we actually start talking about test script, we're going to restructure this slightly to make it slightly more amenable to testing. So what we're going to do is we're actually going to break apart our main function into 3 functions here, and you'll see why in just a second. So let me just quickly do that. What we want to do is call os.exit here with the result of a function called main1. And we're going to do main1, and it's going to return an int. So that kind of makes sense. We've got a problem here, is that this is not going to, so what we now want to do is split apart main1 into main-er, and this is going to return an error. And we're going to pop that in there, and because I'm not actually doing any sort of error handling here, main-er, os return 1, return 0. How's that looking? So yeah, we just split apart our main here in order that we have a function that returns an int, which we can pass directly to os.exit, which is kind of what main is all about. Otherwise, unless you call os.exit with a different value, it's going to exit with 0. So then we've actually split main1 into another function, main-er, so we can explicitly have an error version of main, if you like, where we can return an error instead of panicking or anything like that, sort of referring to Nick's talk. Okay, so let's just check that this still works. Phew. Good, okay. The reason for this will become pretty obvious now. So let's switch to editing main test. And we're going to write, so test example t testing.t. Okay, and now what we're going to run is test script, whoops. This is where test script comes into things. Okay, and test script, we want to pass in t, the testing t, and then we test script.params. And then here, what we pass in is the name of the directory which is going to contain the test scripts. So here, if we just hover over run here for the documentation, it says, so when we're running, this is the entry point to test script, if you like. You just pass it, as we said before, the name of the directory that contains these scripts. Now, we haven't created any of these scripts yet. We're about to do that. And this is all that's actually required, but for one thing. So what I'm going to do is I'm going to cheat here and just steal this here. So there's another thing we have to do here is actually within our scripts we have to sort of create a shorthand for running the code that we have defined in our main. So you can see here, this is where this definition of the main1 function comes in. So in test script it's possible to actually define your own custom commands, and this is the one way of doing it. So here all we're doing is defining a custom command example, so that when it sees the command or the word example in a test script, it will run the function main1. And as we saw, let's just go back to that. Main1 is just calling on to main-er. So this is the way, a very simple way in which you can extend test script with your own custom commands. So let's just remind ourselves what it is we're trying to test here. We're effectively trying to emulate what is going on here when we call go run main.go. We could, of course, go build here and run the resulting binary. So what are we actually going to test? So let's create ourselves our first script, and let's call it noargs.test. And so let's just put a comment at the top to keep it nice and helpful. So test that our example works when run with no arguments. So what are we expecting in this situation? So if we just run example, okay, what we could do is actually just see what this is going to do. So let's just, we've created, I think we should be able to call go test here. Excuse me, go test. We can. And if we run it in verbose mode, we can actually see what the output is here. So this is test script having done its thing. And let's just see, so now go test with -v is actually telling us what it's actually doing. And you can see it's going in to run this test example / noargs test script that we've just created. Then the first thing it does is actually dump out for us very helpfully the limited environment, as I said, that it's running within. And then at the end it says, well, what happens? You can see the comment there, test that our example works when run with no arguments. And then it's run that command and it said standard out includes hello world. Okay, so what we can actually do in this situation is say that standard out should match hello world like that. Let me just check. Then we can run our test again and that passes. Fantastic, okay? So now what we want to do, so that's a very simple script. That is just as if we were the user running it. We're just calling example and checking that the output is as expected. So, and the default is hello world. So now let's have a custom greeting.txt script. Ooh, and check that custom greetings work. So now what we're going to call is example with -greeting hi. And so let's just do something slightly different in this situation. What we're going to do is define inline here. This is inline, this is an archive, this is a file that will be extracted to the work directory. And so this should say hi world, like that. So now what we're going to do is compare standard out with output. Oops. Oh, it's just the file name's a bit longer, excuse me. So now let's check that this works. Go test. Ooh, what have I done here? So it's quoted. Say again?
In the text file, there are quotes that are not handled by the shell.
In the test file itself, custom greeting, this is. Oh, thank you. Very good spot. No quotes needed there. Effectively, if you wanted to have this, if you wanted to pass a space in the middle of an argument, hi there, you'd have to do that with single quotes. It's not double quoted, unlike bash and things. Thank you for that spot. So this is obviously going to fail as well because I've made it hi there. So now let's just change this to be hi and run our test again. So that passes. So you can hopefully see how easy it has been for us to actually quickly change our main function, splitting it up into 2-3 separate functions there, and then quickly adapt it to being test scriptable, and then how quick it is as well to actually add further scripts. Now, we've only just scratched the surface of things today. The full docs cover how to add custom commands, custom conditions, and it tells you in a bit more detail about what test script can do. So with that, I think I've run way over time, and I won't keep you from your drinks anymore. Anybody got any questions, come and grab me at the break. Thank you. Should we, oh yeah.
Code, and the question is, what does it print? So we're going to have a few minutes break, and there's some drinks in the lobby now. Thank you. Okay. Thanks very much, everybody. So it looks like everyone's brains are working through this conundrum, but I'd like to welcome to the stage a guest conundrum solver, Matt Ryer.
Hello everyone. Who knows the answer to this? Who thinks they know? Apart from me. I only know because I looked it up, because I got it wrong. So let's have some guesses there. What do we think this prints out? It's alright if it's wrong. Panic? Well, who knows what this does?
Ordering.
Yeah, so, yeah, these, in the items, the type of that is a slice of array, a byte array, which contains 2 items. And this is essentially slicing those pairs. So it's turning an array of 2 sizes into a slice. And since there's no numbers in here, it selects the entire set. So if you read that knowing that, then it seems obvious to me that it's going to just print out 1, 2, 3, 4, 5, 6, 7, 8 in pairs in the same way. But that's not what happens. There's something else weird going on here. If anyone's got any clues, any ideas? Yes?
The second parameter of append would be a slice that is passed straight away. So it's like a single slice of items.
So this is appending to this A variable, and the A variable is a slice of bytes. So it's just adding these items. Well, let's have a look. This is really weird. Let's build some suspense. Not my joke. So, what? So anyone got any ideas why it's printing that out every time? Yes?
Don't we need to have for I item range items and then A equals append A items I?
Right. So yes, there's something about the fact that we're reusing this item here. Within this loop, that item is getting reused, and it's essentially referencing these slices. But it's the same. It's basically the end value because it's reference. It's like a reference. It's setting that each time. So if you were to intercept this and watch it as it goes, you would see it probably go 1, 2, and then both of them would change to 3, 4, 3, 4, and then there'd be 3, there would be 5, 6, 5, 6, 5, 6, and you end up with this, which is 7, 8, 7, 8, 7, 8. And there's a bit more of an explanation here. And essentially, it's to do with that you need to sort of watch out for that variable. It's being modified as you go. And we've appended the slice, which is as you know, it's a pointer and a size. So you're changing that each time instead. And this is actually a fix, although I prefer the fix that was mentioned before. If you did this, what you then do is within this block, you're capturing then the item. So when you append the item, it's a different item each time. And that's how you could catch it. Another way would be to use the index and directly access it as the gentleman said.
What about if you spread them?
Sorry?
What about if you spread them?
Well, the type is
An
this.
array. Well,
Yeah.
the item is an array of big size bytes. What if you spread them?
Well, if you spread them, you wouldn't be building up this type. You'd be building up just a slice of bytes, not a slice of bytes.
Ah,
Yeah. But yeah, there we go. Bonkers.
So now our brains are all melting. So just as a reminder, JetBrains license raffle, get involved with that one. The keyword is groceries. The .go ticket, if you're not going to go for that one, I am. It's London, gophers.london/.go, and the keyword is Paris. And also 10% discount with the code GOLONDON, so that's for everybody. That's free. So we've had 2 talks already tonight. We've got our keynote, or headlining talk today. And this is Benjamin Bryant. He's going to explain how you can get production experience, which is the Holy Grail. Please welcome Ben.
Before I start, put it on me? Oh, how do I do that? Sorry, thank you. Before I start, I just wanted to double check because I think the closing is like 9 o'clock, so I have how much time? Like 29 minutes?
Yeah, 39.
Okay. Okay. Anyway, so I'm just gonna put my timer here so I don't go over. So yeah, my name is Benjamin Bryant, and today I'm going to be talking about my talk, which is basically the Go in production experience, which is my experience trying to get production experience using Go. And so short background to myself, I joined the Go community back in August 2018. I've been to most London Gopher meetups since, and back in March 2019, I did a talk in hopes of getting a t-shirt. Now, the aftermath of that talk is I actually ended up having the opportunity to apply for a job Go job as a back-end engineer, and I was actually promised free clothing. Unfortunately, it never materialized, but what was more important is that I had the interview. So first things first was stage 1, the video call. I arrived in a shirt across my camera. He was lying on a beanbag, so like the balance of power was very palpable. But after that was the technical task, and so I wrote it up, I completed it, I wrote tests, and then I had to go and review it. And then the next email I got looked a bit different because there are no emojis in it. And so I thought at the time, clearly I'd move on to stage 3. Things were getting serious. And so as I queued up in basically in a restaurant, I'm going to order some food, I opened it and I was just assaulted with what I didn't want to hear. It was a rejection email, and I fell into an endless pit of despair that I just couldn't recover from. What I remember, guys, I have 25 minutes. Sorry. But what I remember is that the guy who was serving me, he said, would you like to eat in or take away? And I remember distinctly saying, I'm sorry, sir, I don't understand that question right now. And so the next thing I had is that I just asked why, but very kindly. I even had an emoji on my email, maybe there's someone back. And they basically just sent back, you need more production experience. This was a new sentence to me. I had no idea. I'd never heard this word before. So I did what I usually do when I hit a problem. I went to LondonGophers to complain about it and figure out what exactly production experience was. So by dodging a number of questions, most of them were like, hey, how's your new job? I basically had to kind of figure out what was production experience by asking people. And as far as I can understand, it's basically in the eyes of the beholder, because every single person I asked gave me a different answer. And so I decided to kind of put it together into my own definition, and we'll be using this definition moving forward. But I mean, just for this talk, not in general, but for me, this is my own definition, and it's have an experience or understanding of how to work on a rapidly changing system that is in heavy use. Heavy use here can just basically mean you have lots of users using your system, and that's what we're going to be running with for the remainder of the talk. So the next question I asked people was, so how do I get production experience using Go? And I was given, once again, a myriad of answers that I've refined down into 3 circles. The first one was try a personal project. The second one was get a job, to which I replied, I tried. And the third one was contribute to an open source project. And so what we have right now is we have 3 variables. The next thing was which was better. And that could be maybe a hypothesis or something, a goal to go for. And I remembered in my pit of despair that there was one sentence that was very important, and it's that I could reapply in 12 months, and that was a timeline. And by all their powers combined, we could create an experiment. And so I decided to split my life into 3 branches. On branch A, I would focus entirely on a personal project. On branch B, I would focus entirely on getting a job. And in branch C, I would focus entirely on contributing to open source. So initial aims: can each branch achieve production experience? Which branch is the fastest? And one constraint I was going to do is that branches shouldn't really interact with each other because that would ruin the experiment. So let's start with branch A, a personal project. First step, picking a project. luckily, a year ago, I had like a single player game, which I kind of called Bejeweled with Pipes, and I wanted to maybe add a versus mode to it. And this was like my first prototype. I figured, okay, we have 2 clients, one sends up a score, and then you get the enemy score back, and you're using WebSockets to connect to each other. And that's what I kind of had to go into first. So the first step was figuring out server hosting. And there were so many options, and like a big theme of branch A is going to be decision paralysis, because I had no idea which one to pick. Eventually, I went with DigitalOcean, but there wasn't really a solid reason for that. And when I actually went into that, like I was shown like this screen, like there was no UI, and I was trying to figure out how to set up like a sort of Linux from scratch. I had no idea what I was doing. And so the next thing I needed to do was move from using a game framework to a game engine. This isn't actually necessary to go, but like I was talking to other, I basically wanted to try and not have the client be the important part. I was more focused in making the server the part I was focusing on. And because Godot essentially has a nice UI, it meant building the game again was actually much faster. So now we enter the continuous deployment arc. And so I figured production, in order to like do the whole rapidly changing system, it's very important to maybe, I guess, deploy quickly. And so I kind of just heard about like GitHub, Jenkins, and Docker. Now the first thing I had to investigate was Docker. Now there's a really nice video here that's on their website and will introduce you to Docker, but I'm not going to explain it now. And but one thing they didn't explain was how to install Docker on Windows 10 Home, which actually required 3 different installation things, and also I had to go into my computer BIOS. I'd never been there before. But the next thing to do is that I had to figure out pipelines. Now, when I first saw a pipeline, it was kind of intimidating, but all it really was is like everything's in stages, so it's kind of just like a number of bash scripts in sequence. And when I like realized it was just that, in future, like this was a few months later, I was able to like make a really cool pipeline where I was like downloading code from my game, downloading code from my website, exporting my game into HTML5, putting it into my website, and deploying it. And that would all take like 2 minutes or so to like deploy. And one of my really awesome memories from this is when I was showing my game to someone, but I set the time limit to 5 seconds. And so I basically just logged into GitHub on my phone, went to the file, changed it to 90 seconds, committed it, and then in 30 seconds, after refreshing the page, it was fixed. And I was like, surely this is production experience. And so the next thing I decided to do was basically move all my client-side game logic into the server. This was simply because I was kind of told that you can't really trust the client, so I just went all in on that. And the only thing I read and the only thing that the client does is send up input, and everything else is sent back as game information. So the next part, which is now in August, is registering a domain name. I went with Namecheap because it spoke to me, and and then the next thing I needed to do was find players. And I didn't have a way to advertise this, and so I thought, if I can't, find friends, I'll make them. And so I made up my own like robot that could solve my game for me, which meant that I could actually play a game against my robot, but I slowed it down because it was better than me. And so but I thought maybe I could use this for like future load testing, because what if I could create games where like 1,000 robots are versing 1,000 robots? Could I really test like how far my like $5 first server could go? And the next thing, because I thought to make it look really production ready, I need to get an SSL certificate. But luckily, times have changed. Like Let's Encrypt and AutoCert made it really simple to essentially just strap on the certificate to my website, but the only problem is that AutoCert required port 80 and port 443 to be accessible, and I had one server. So I had to try and figure out how to do a reverse proxy that could basically make my game logic service and my website secure, but also using secure WebSockets, and that unfortunately took a month. And then like at the end, we finally, after that, I'm going to be honest, I kind of hit a bit of burnout, and I was like, we're kind of done with branch A for the time being. And so a good thing about this branch is that I got high exposure to the basics of like quite a few programs, but the things I didn't really enjoy was that there was like so much decision paralysis. I had a bit of burnout. As you probably noticed by the timeline, I was slowing down as we were getting later into the experiment. And like, although like, I only at maximum played with like 2 people, so I don't know if that really counted. The next thing we moved on to was get a job, and I went in here skeptical because I figured like, So I went in, I decided to write a cover letter because I was taking it really seriously. And then I researched the company, put it in, I had it spell checked 5 times by my mum. And then I basically went in and then like I got a call and they were like, hey man, dude, your cover letter was sick. And I was like, I felt so exalted. And then after that, we moved on to stage 2. I was getting flashbacks, but this time there was no technical task, so I felt a lot braver. This time, all I had to talk about was something technical I'd been working on, and I had to do a small, like, typing over the screen thing. And then we were in stage 3, but the technical task came back. And so this was just technical task review, architectural design, and behavioral. Unfortunately, I hadn't really, well, I failed one previously, and I hadn't done the other 2, so I kind of went into these with a bit more trying to figure out how to prepare for it. And the first preparation is that for the technical task, I kind of went in as simple as possible, so that way I could explain it as well as possible, and maybe even expand it, because I think last time I might have like, well actually, they didn't really tell me what I did wrong, but I assumed that I, you know, kind of possibly just didn't feel confident in my explanation. So the next one was the architectural interview, and all I could really do is just go on YouTube and notarize everything. And so after that, I then went on to the behavioral interview preparation, where I basically just found all these questions online. I figured out the STAR, I mean, I didn't figure it out, it exists. I used the STAR method and basically had an answer for every single one of these questions. Unfortunately, they didn't ask a single one, but I still felt really prepared. And then after that, all I could do was wait for the results. They said they'd call me on Friday, so next Monday I got a call. And yeah, essentially, I ended up with a job offer, but it wasn't for the one I applied. It was for an unlisted graduate position. And so after this happened, I was like, oh, well, I guess I just kind of got lucky then. And so there was no dancing this time. I just kind of felt like, oh, all right. Because like, although the road to production had been opened, it kind of felt very anticlimactic, but more importantly, it just wasn't very useful, because if someone messaged me and asked, hey, how do I get production experience? At this point in time, all I could say was, dude, just apply for a job and hope there's an unlisted entry-level position. It's that easy. And so moving on, I decided to go back to branch C, as in like, so here we are, back in time again. And I started basically by going to the trending page and looking at everything, and I was like, okay, let's do this. And then 3 months passed and I hadn't done anything, and I realized this was really, really bad, because I was like, not only that, but I didn't actually understand how to contribute to anything, because I don't know, because even though some people did say, hey, just go to like a new issue for beginners, I did, and it did not look like a new issue for beginners, and like, I just didn't really know what to do. So I had to come up with a way to basically say that I'd done my homework when I hadn't actually done it. And that's when, after reading a few things online, I realized, LondonGophers is a part of Go. Go is open source. Technically, I've already contributed. And so if we go back and like rejig the timeline, this is basically what happened in branch C. I just came here every single month, but then something else occurred to me, and it was the April one. Because in April, LondonGophers was hosted at the place where I currently work. And so I was like, oh, if I include this, then we're going to be breaking the experiment. And then I thought, well, if I think about it, the entire flowchart of branch B was essentially just to go here and like listen to every single company that had been here and like target them and put them on a list and basically say that I was going to apply to all of them. And so after that, I decided to revisit branch B. And to do this, I also went to most people who interviewed me and asked them, like, why did they decide to like take a chance on me, essentially? And so for the first one would be the application. So even though my cover letter was really, really cool, if we go back in time and focus on like the bits of work I did before I even started this experiment, in February I actually met one of the developers at the pub, and while I was talking about what I was going to be doing, in April, I actually felt more confident going up to a group of the same developers and being like, hey, I'm looking for a job, what can I do? And I felt really embarrassed. I didn't even want to ask for a referral, but even though I applied, one of them went out of their way to basically recommend me. And so before I even like submitted my application, I already had all of that behind me. Next, for the technical hangout, once again, we have the prior work I've already done, and then in May, when I came here to London Gophers again, I had the interview the next day, and I was talking to people, and I was essentially asking, I haven't really worked on anything technical. I mean, like, I'm doing this thing, but I haven't finished it yet. And, like, they basically said, well, why not just mention the story? Like, say you failed but now you're working on this. And he basically said that some companies like the idea of, like, you recovering from your failure. And so I decided to use that. But also in the pub at the same event, I actually met the two people who were going to be interviewing me. And so what they actually did is that they decided to switch the interview with two other people. So it kind of felt like we were both unprepared, which meant that it was equal footing. And so the next part was a technical task review, once again, prior work. But as soon as I walked to the interview, one of them said, oh, hey, I recognize you. Like, I looked up your talk beforehand. And so I kind of felt more comfortable going in. For the software architecture interview, I'd been exposed to a number of concepts here, and so it felt more like revision than learning something for the first time. This is like branch D, it doesn't really exist, but I thought I'd mention it, because learning how to dungeon master in Dungeons & Dragons actually kind of helped with a software architecture interview, because as a dungeon master, you basically have a plot, and your players pick holes in it, and that's basically what a software architecture interview is. And so the last one was a behavioral interview, which branch B kind of helped in this, because I kind of like had a job that I didn't really enjoy, but there were still stories and things I could say from that. And the advice about acting on failure was actually very useful when like answering every single question I had prepared, because I felt more comfortable basically saying that, yeah, I've kind of failed, but then I did this. And so at some point, I decided to end branch C, because as we were going down this trail of thought, I kind of realized that the experiment was kind of over at this point. So even though like I found out that, you know, contribution can have a broad interpretation, it did like break everything. And so I think all in all, we can say that the winner here is all branches, because when they all came together into some kind of master branch, you could really feel that, you know, this could be the way to production. But unfortunately, within the reins of the experiment, that means that they're all disqualified, because the actual constraint was that they shouldn't work together. So even though in the eyes of science, this entire experiment was a waste of time, I felt that I learned quite a few lessons. Lesson 1 was build yourself to be the right person, so when the right time comes along, you're ready. Simply because I kind of feel that if I hadn't I kind of blundered into a bunch of things that just so happened to work out. And so moving forward, I kind of wanted to like maybe make a learning blueprint of what I could do. Like say, for example, this question mark is like becoming a Rust developer or something like that. I could maybe work on something in my spare time and then talk to people at either my job or part of the Rust community to basically find out what areas would be a good areas to try and study on. And then once I have that, I can then go back and work on something as well and come back with more questions. And by having this repeating cycle, if I try again to go for whatever like that goal is, even if they say no, I can bring that experience back into the circle and do it again. And so that was one takeaway. The other one is that for me, I need to work on giving actionable advice and feedback, because while going through this, the best feedback was the ones that I could actually work with. And like, that's just something that I need to work on. Like if I have like the ability to essentially tell someone what might be a good idea to do, and in a way where they can go away and actually work on it, then surely that's something I could try and do myself. And the third one is that even though it really sucks sometimes, try to understand things, because I found a lot of times when I was working in branch A and doing my own thing, I kind of like skipped reading things, which kind of like bit me in the butt a bit later on. And so sometimes like you just need to like sit down and read. And yeah. And the final lesson was that everything is obvious in retrospect, because I understand that like all these lessons are kind of like live, love, laugh in sense of obviousness, but at the same time, at the time I started this, none of it kind of felt obvious. And so even though like to me, like I was kind of hoping when I started the experiment that I would have like a end conclusion, all I can really do is talk about what happened. And so special thanks to OpenMoji. I've used a lot of their images today, and I thought I'd give them credit. Also for how to contribute to open source, because on this page, if you scroll down, the first thing says you don't have to contribute code, which really, really helped with like, you know, finishing this. And one final thing, in the end, 10 months later, he actually did pull through. He came. And so let it not be said that Dominic Green does not fulfill his promises eventually. And so yeah, if you guys like if anyone on the live stream start watching the beginning, like I feel sorry for Dom because he's not here and can't defend himself. But like, you know, redemption. And so yeah, thanks for listening. I've been Benjamin Bryant. The end. Oh, do you have any questions or anything?
I think that's a really, really good message because it's good for people that want to get experience in production, but also for the people that are kind of setting the, the kind of exams and doing the interviews and stuff. It's really helpful to remember what the experience is like from the other side, and I think that's really, really helpful. Certainly helps me when we're doing recruitment at our place. But anyway, I'll not ramble on because we've got the pub and homes to get to. But just thanks again to our recurring sponsors, Vistas Recruitment and Utility Warehouse. And the next meetup will be at Deliveroo, a familiar name, and that's February the 19th. And then March 18th would be the next one, and that's to be confirmed. So just finally, a huge thank you to Sainsbury's for hosting us here, and a huge thank you to all of you for coming. Thank you.